Okay, so this video builds on the previous one on basic atomic structure. This video tries to explain the three main types of chemical bond that you'll find in GCSE chemistry. Okay, so before we look at bonds themselves, why do atoms actually form bonds at all? So it comes down to one thing. Atoms try and reach their most stable state they can, and this they can do by rearranging their electrons. The most stable state any atom can have is one where its outer shell of electrons is completely full. There's one group of elements that already have this. Those are the noble gases, group 8. All noble gases have a completely full outside ring of electrons to start with. As a result of this, they never form bonds, or very rarely, and as a result are basically completely unreactive. So elements like helium and neon, you never find them in compounds. They only exist as single atoms in a gas state. Okay, so the first form of chemical bonding you need to know about is ionic. Now, the key here is knowing when it's going to be ionic, and what you're looking for is a metal and a non-metal. So here we have a sodium atom and a fluorine atom. At the start of the process, the sodium atom has a single outer electron. The fluorine is one short of full. So to get them both stable, we transfer one electron from the sodium to the fluorine, and they each become a charged ion. The metal always becomes the positive ion. Now, if you ever get stuck on this, look on the back of the chemistry datasheet and you will find a list of charges and ions, so you'll know that sodium is always a positive one, and fluorine always becomes fluoride, a negative charge. So, important facts to know here. The reason this actually results in a bond, well, if the sodium is positive and the fluoride is negative, you have a pair of opposing charges. And whenever you get opposing charges, they're attracted to each other by what we call an electrostatic force. So an ionic bond is actually the electrostatic force which is attracting these two atoms to each other. Okay, the second type of bonding is a covalent bond. Now, this occurs when you have two or more non-metal atoms. So in this example we have a group of 5 atoms forming a single covalent molecule. But it could be as simple as 2 hydrogen atoms. 2 atoms, they're both non-metals, it's covalent. Okay, so the difference here. The hydrogens each have a single electron. So because we have 4 hydrogens, we have 4 electrons from those hydrogens. Now in the outer ring, carbon also has 4 electrons. It needs to gain 4 to become full, so by sharing its electron with a hydrogen, it gets a share in an electron back. These electrons are effectively in both atoms. So the carbon sees itself as having 8, and so it's stable, and the hydrogen sees itself as having 2, and so it's stable. Remember, hydrogen only has a single ring, and that first ring can only hold 2, whereas carbon, although we haven't drawn the second ring, there is actually an inner ring inside here that's already full. So this ring is its second, which is why it needs 8 to be full. Covalent bonds come in 2 varieties. We have simple ones and giant ones. We'll look at those in the next video when we look at the properties of these different types of material. Okay, so here's the last type of bonding. You only have metallic bonding if every atom present is a metal. Doesn't necessarily have to be the same metal, but they can't be non-metals mixed up in here, otherwise it's not going to work. Right, so if this was an ionic situation, the metal atoms would want to shed their outer electrons, which would then be picked up by non-metal atoms. But here we don't have any non-metal atoms, so instead the electrons are just left. They're free in between the positively charged metal atoms. We call them delocalized because they don't belong to any one particular location. They're not attached to an atom, they are literally free to wander around through the metal. And that's where the opposite charge in this system is. We have positively charged atoms surrounded by a negatively charged sea of electrons. So again, we have an electrostatic attraction here between the positive atom and the surrounding negative charge, which is what holds the whole thing together. So What you need to know from this video are the three types of bonding: covalent, ionic and metallic. You need to know when you use them, so covalent if it's all non-metal, metallic if it's all metal, and ionic if it's one of each. And you have to know the basic structure of the bond, the idea of a transferred electron with charges associated with it, of shared electrons if it's covalent, or in this case the delocalized electrons of a metallic bond. If you're happy with this, move on to the next video where we'll look at the effects these bonding types have on the materials that they make up.